Alright, welcome to your final video 3.7, looking at how to separate a mixture and just a quick review. Main objectives are to list and describe several techniques that we can use to separate mixtures. Make sure you take away all your distractions and pause, rewind as you need to, and take some extra notes in the margin should you need to. So, separate a mixture. So, for example, before I even say anything here, so if I have like sodium chloride and water, H2O, and I mix them together, I'll have salt water. I'll have a mixture of the two things. I literally take the two things and mix them together, and now I have a mixture. Now, because the substances in a mixture are physically combined, the process used to separate a mixture are physical processes, and they're based on this is important, they're based on the differences in physical properties of the substances. Okay? So again, we physically mix them together. There should be a way to physically separate them back as well. And the way you separate them is you look at the differences in physical properties. So what are some properties that sodium chloride have that we can use to separate them? That's what you want to kind of think about how you're going to separate your mixture. Let's take a peek here. So one technique is called filtration. This technique uses a porous barrier, usually some kind of filter paper, and it separates things by particle size, liquids from solids. Okay, so up here, if I had a mixture of a liquid and a solid there, and I pour it through, the solid residue would get stuck in the filter paper, and the liquid would go through the filter paper, and we collect it down here. Again, we call the collection of stuff the residue. We call the stuff down here the filtrate. One more thing we can also add to this, sometimes you dissolve some things, and if things are dissolved in the water, they can also go through. So dissolved stuff, homogeneous solutions that have dissolved solids, they can go through, but any kind of solid residue gets left behind. Up next we have distillation. Distillation separates two liquids. That's kind of their key there. It's a liquid-liquid mixture, and we separate them based on their different boiling points. For example, if we have water and we have ethanol, 5 there. Ethanol boils at approximately 78 degrees Celsius and water is at 100 degrees Celsius. So as I raise the temperature will actually stop completely right here, and what will happen is the ethanol will start to boil off. And when the ethanol starts to boil off, it goes up and it keeps continuing through as a gas through this chamber here, and we call this thing here the condenser. And basically the gas will cool back into a liquid, and then when it cools back into a liquid and condensates, we collect that other liquid over here. So the ethanol would be collected over in this chamber over here, and the water, because it boils at 100, most of the water will actually stay down here in the solution here, and we won't collect it. So you can separate two liquids from each other based on their differences in boiling point. That's the physical property we try to take there. The next one is called crystallization. This is how you can get a dissolved solid back from a liquid mixture. So this is kind of like the table salt and water one. So if you have table salt, sodium chloride dissolved in H2O in water there, the way you can get the sodium chloride back from the water is you can either, take a long time, let the water evaporate slowly. As the water level here continues to go down and go down, basically these particles of sodium chloride get back together as solids and they form a crystal on the bottom there. You can also do it a quick way, which would be to vaporize or boil it away. So if you get rid of the liquid component by evaporating or boiling it, and that goes away, what's left behind is the salt. And in this example here, you can see some salt harvesting where they have like shallow pools of water, and they use solar radiation to evaporate away the liquid. Well, the salt starts to crystallize, and they can take these long rakes and rake them up like this, and they can get the salt from that. So crystallization is another separation technique. Probably the trickiest one is chromatography. Chromatography can separate, and our best example, this one is probably ink. Ink, like a black pen or a blue pen or a green pen, the ink is actually made of different dyes. And in that ink, you can separate them with chromatography. This technique separates based on the tendency of each substance to travel across the surface of another material. And how they go across that other material, they can separate based on how well they attract. So here's a dot right here, and as the water wicks up the paper, and the water continues to wick up the paper here, in this case it gets up to about this level right here, the different dyes in the ink here, they will separate out because of how they attract the paper. The things that attract to the paper the most, they go very slowly up the paper. The things that attract to the paper the least, they go up the paper very fast with the water. And there are some things that have intermediate attraction for the paper. They travel up somewhere to medium speed to about here. And what happens is as they rise up, based on a strong attraction or weak attraction for the paper, they will separate out. As you can see here, here's where the water level is on this chromatography apparatus. And you can see different things are separating out based on how fast they travel with the water. Alright, and that's chromatography. There are other separation techniques out there. There's more than what we just discussed in the video here. The goal, though, of any technique is to target the different physical properties of each substance in a mixture. You'll be doing a lab in class where you'll be given a mixture of iron, sand, salt, and sesame seeds. We would like you to separate those things out onto a piece of paper towel, which you'll divide into 4 quadrants, and you'll label it iron, sand, salt, and sesame seeds. And your goal then is to take this mixture of stuff, they'll be in a beaker or in a cup of some sort, and you try to separate them out into those 4 things there. You're going to go for quality, how well you separate it, and you also want to go for time. So first I will grade you based on I'll award a bonus point to the group that has the best quality. And then if there's 2 groups with the same best quality, we'll go by who did it the fastest. So kind of think about how you're going to do that. Lastly, just to kind of review classifying matter, don't forget that matter is mostly a mixture. Most matter is a mixture. And a mixture is when you have 2 or more of these pure substances mixed together. Pure substances can be just elements, which you can find in the periodic table. They're the simplest form of matter we have. Or they can be elements bonded together to make compounds. And those 2 things, they can convert to one another. If you do chemical reactions, you can bond elements to make compounds, and you can break the compounds back into their elements with a chemical change. And if you have 2 pure substances mixed together, you have a mixture. And how they are mixed together means you have a heterogeneous mixture, which means you can see the different components, different, hetero. Homogeneous mixtures are ones where they're mixed so well together they look the same throughout, homogeneous. And this is kind of how we classify our matter. Heterogeneous mixtures, homogeneous mixtures, or are they pure substances like elements or compounds.